Hello everyone, so let's proceed in solving inexact differential equations with another example as shown. Y prime is equal to 3x squared y all over x cubed plus 2y to the fourth. So in solving this, if we check for separability, it will not happen. If you check for homogeneity, it will not happen. If you check for exactness, it will not happen too. If you check for inexactness, yes it is. And if you check for case 1 to solve for v, it will not happen. If you check for case 2, so let's try. But before that, check my previous videos on how to solve differential equations using the tests that I mentioned a while ago. Okay, right now let me just show you first that this differential equation is inexact, then proceed with case 2. So we have here dy over dx is equal to is equal to 3x squared y all over x cubed plus 2 to the y fourth, such that we can reduce the original differential equation into mdx plus ndy form, and we will have 3x squared y dx minus, just do the math there, x cubed plus 2 to the y 2y to the fourth dy is equal to 0. Correct? Now let's try to see if this is exact, and we know it is not, but let's just solve for the partial derivative of m with respect to m dx. So differentiate this with respect to y, which is equal to the partial derivative of 3x squared y all with respect to y. Since this is our independent variable is y, therefore x is considered constant. Separate the constant first, and what is the derivative of y with respect to y? That is just 1. Let's have the partial derivative of n with respect to y. Okay, so let's solve for the partial derivative of n with respect to x and dy, so we will differentiate with respect to x, equal to the partial derivative of negative x cubed. I'm going to distribute the negative, minus 2y to the fourth. This is our m all over with respect to x. So x is the variable, y is considered constant. What is the derivative of negative x cubed? That is our rule for a differentiation, negative 3x squared. And since y is considered constant, the derivative of a constant, this one, that is just 0. So our partial derivative of m is 3x squared, while the other one is negative 3x squared. That is still considered inexact. Okay, so now let's proceed with solving for the integrating factor v. But like I told you, we will just proceed with case 2 to minimize the time for our video. And then here we go. What to do for case 2? That is, if case 1 is nmn, case 2 is mnm. Case 2 is mnm. That would be m multiplied by nm. So n minus m, which is, this is over, what is the partial derivative of n? So we will consider this one. Can you see that? We will consider that. All over with respect to y. Now let's try. What is our m? Our original m? This is our original m. Okay? 1 over 3x squared y multiplied by, what is this? What is that? This is negative 3x squared minus our partial derivative of m, that is also 3x squared, but positive. Simplifying, this would be negative 6x squared all over 3x squared y, right? Which is equal to negative 2 over y. So as you can see, when you do this process, the resulting function is a function of y. All the variables that you can see is y. Therefore, this is case 2. And your integrating factor v will be a function of y also, which is equal to, what is our integrating factor? V is equal to e raised to the integral of g of y dy, or, now I'll just make that bigger. Integral of negative 2 over y dy. And what is the integral of negative 2 over y? That is equal to e raised to negative 2 ln y, which is equal to e raised to ln y raised to negative 2, laws of natural logarithm, and e raised to ln, this becomes y raised to negative 2. Therefore, this is the one that you are going to multiply to the original inexact differential equation, which is this one, to make that exact. Okay? So right now, we will be multiplying this integrating factor y raised to negative 2 to this inexact differential equation. We are not changing its value, but we are just multiplying both sides to make this differential equation exact. So that will become 3x squared y dx times y raised to negative 2. That will be 3x squared, 3x squared over y dx minus x cubed over y squared plus 2y squared dy equals 0. Now let's test for, this will be our new m, this one, and this will be our new n, that one. And what we'll be doing right now is to test for the test for its exactness. We'll make sure that this is already exact. What will be our partial derivative of m with respect to dx? So I will differentiate that with respect to y, be equal to 3x squared over y with respect to y. So x is constant, And what is the derivative of 1 over y, or y raised to negative 1? So that is power rule, which is negative y raised to negative 1. That would be negative 1 times y raised to negative 1 minus 1, which is negative 2. So that makes this negative 3x squared over y squared. How about for the partial derivative of n with respect to x? So we are checking right now the exactness of this new differential equation, which is equal to partial derivative of negative x cubed over y squared minus 2y squared with respect to x. So in this one, y is constant. So derivative of negative x cubed over y squared, that would be negative 3 x squared, power rule, all over y squared. And the derivative of negative 2y squared, since y is considered constant, that would be 0. So as you can observe, our new partial derivatives are now equal. So therefore, this is already an exact differential equation. And how to solve for the solution? We will solve for f prime and f prime prime. F prime would be equal to the integral of m. M is 3x squared over y. If integration dx, so this is with respect to x. Oh no, got that. M with respect to x is equal to the integral of 3x squared over y with respect to x, and x is the variable, y is considered constant. What is the integral of x squared, 3x squared, or x squared? That would be x cubed over 3, power rule. So 3x cubed over 3y, which is equal to x cubed over y. How about for f prime prime? F prime prime is the integral of n with respect to y. And what is our n? N is negative x cubed over y squared minus, I am distributing the negative here, that one to this one. Okay, so minus 2y squared with respect to y. What is the integral of negative x cubed over y squared, considering x as a constant? So this would be negative x cubed and y squared over y squared, or y raised to negative 2. So what is the integral of y raised to negative 2? Power rule. That would be y raised to negative 2 plus 1, or negative 1, over negative 2 plus 1, or negative 1. Then minus integral of 2y squared. That would be negative 2 y cubed over cube, or 3. So simplifying, this term will become x cubed over y minus 2y cubed over 3. Now we have the f prime and the f prime prime. We can now get for the final solution. F is the union of f prime and f prime prime, which is equal to x cubed over y minus 2y cubed over 3 is equal to c. Okay, simplifying, we will have a final solution. Multiply both sides by 3y. So this becomes 3x cubed minus 2y to the fourth is equal to 3cy, or 3c is just the same as c, like I told you, okay? So this is cy. And that is our final answer. Is it correct? Is there any correction? Do you have any correction? So if there is none, thank you for listening. Goodbye.